So let's investigate a little more with the connection between a derivative and whether a function is increasing or decreasing. So first, I guess we should define what we mean as increasing. So if I is an interval, an open interval from a to b, a function f is going to be increasing on that interval if f of x sub 1 is going to be less than f of x sub 2 for any x sub 1 and x sub 2 in that interval where x sub 1 is less than x sub 2. So basically that means as we're following our graph from left to right, it's moving up. And then likewise for decreasing, same setup, except we would say that the outputs, f of x sub 1 is greater than f of x sub 2 if x sub 1 and x sub 2 are in that interval and x sub 1 is less than x sub 2. If you draw a picture, it should be very clear to you. For example, let's say we have that, and let's pick an interval, how about from here to here. If this is A and this is B, then we can say that if we pick any 2 points, let me move this one over, within that interval, we'll call that x sub 1 right here, and the other one is x sub 2. Then the output, f of x sub 1, is going to be greater than f of x sub 2. So that means that it's decreasing over that interval from a to b. And then likewise increasing, just the opposite. So what you don't want to do is memorize all these facts as we start to get into derivatives, first derivatives and second derivatives, is you want to understand what they're saying and get a visual picture for it to help you remember it. Now, IB would refer to this as strictly increasing or decreasing. They include the endpoints when they're talking about increasing and decreasing. So they would say it's increasing on I if f of x sub 1 is less than or equal to f of x sub 2. And if it's decreasing on the interval, then f of x sub 1 is greater than or equal to f of x sub 2. So it's a little more subtle to talk about what's happening at those endpoints as well. We say that a function's monotone if it does not change from increasing to decreasing, or vice versa, on an interval I, so monotone. All right, so let's connect that to our first derivative. So if the first derivative is greater than 0 for every x on some interval, then we can say that our function increases on that interval. And if the derivative is negative on that interval for every x, then we say that it decreases on that interval. Now here we're referring to talking about a function increasing or decreasing on an interval. What about at a specific point? And that's where, calculus gets a little more in-depth, and IB just refers to the intervals. But if f prime of a, so at a certain value a, if the derivative is positive, then we say that our function is increasing at that point. And if f prime of a is less than 0, then we say that our function is decreasing at that point. So it's the difference between an interval or a specific point. Now, focusing on this at a point, so if the derivative is positive, it's increasing. If the derivative is negative, then it's decreasing. So can we say if a function is increasing at x equal a, then its derivative there is going to be positive? Well, the answer to that is no. And a counterexample, how about y equal x cubed at x equals 0? So if we look at the function, let's go ahead and graph that very quickly. Y equal x cubed. The domain of this function is all real numbers. And we would say that this is increasing everywhere. Because if we put a point on our curve, as we travel from left to right, our outputs are always greater than it was at the point before it. So this is increasing everywhere. So therefore we should say that it's increasing at 0, but the derivative at 0 is going to equal 0. So the derivative is not positive yet, it's increasing there. So going back, let's make an arrow for this. So if the derivative at a point is positive, we can say our function's increasing. And if the derivative at that point is negative, we can say the function's decreasing. But if the derivative at that point equals 0, then we have to investigate further to see what's going on there. Okay, now let's go back to an IB type question. Let's find the intervals or interval where this function is increasing or decreasing. So what we want to do is we want to find the derivative. And so that's easy enough. 12x cubed minus 24x squared. And we want to figure out where the derivative equals 0. And so we could factor out 12x squared, and we're left with x minus 2. So when x is 0, that's a root of multiplicity 2, and when x is equal to 2. So all we want to do is make a simple number line, and please label this. So I'm going to have x, and when x is 0, or when x is 2, and then under here I'm going to denote f prime of x. And so I know the derivative at 0 is 0, and the derivative at 2 is also 0. I want to find out what's happening in between there, positive or negative, and then I can say if my function's increasing or decreasing. So, an arrow here. Let's start with anything that's less than 0. So if I pick a value less than 0, and it doesn't matter what value, because I know that my function, my derivative is not changing signs over this interval, because if it was, I'd have another 0 here. So let me pick a value, I don't know, let's say -1, and let me plug that into my derivative. It's usually easier to plug it in here, because I really don't care about the exact answer, I just care is my answer positive or negative. So if I plug a -1 in here and square it times 12, that'll be a positive value. And a -1 minus 2 is a negative value. So I'm going to have a positive times a negative, which gives me a negative. So that means our function's decreasing when x is less than 0. All right, let's pick another value. How about something between 0 and 2, like a +1? So when I plug 1 in here, this is going to be positive. Plug a 1 in here in the parentheses, this will be a negative. Positive times a negative, I get a negative again. Okay, and then finally, let's pick a number greater than 2, like 4. When I plug it in here, this is going to evaluate to be a positive. 4 in here makes this a positive. Positive times a positive is a positive. And so we have it there. So for our purposes in IB, we're going to say that our function is increasing over the interval from 2 to infinity. And like I say, they include the 2. So you could also write this as x is greater than or equal to 2. And then we would say that it's decreasing from -infinity to 2. And they would also include the 2 for that, which I don't like, but following their protocol. And you could also say x less than or equal to 2. All right. So there's a few problems in section 18C, starts on page 487.